This section is about addition and subtraction of radicals. So addition or subtraction of radicals. So what you need to remember, just like how you do algebra, you can only add or subtract what we call like radicals. Okay, so let's make sure you understand what is considered to be like radicals. Like radicals, what they have to be is they must have the same radicand and variables raised to exactly the same exponents. So let's make sure you understand what we're talking about. Take for example, if you have 5x radical 6 and you have say 2x squared radical 6, these are unlike radicals. Okay, meaning you cannot do anything with them. Take for example, if you have radical 3 and radical 5, they are unlike radicals. So what are considered like radicals would be, for example, if there was a 7x radical 6 and a 3x radical 6, for example. So if you compare the variables, they're the same, and the radicand is the same. So these are what you call like radicals. Okay, so what you do is you will add or subtract their coefficients, meaning the number in front, but you have to keep the variables and radicands. So, for example, if you are given, let's say 5x radical 6 plus 7x radical 6 minus 3x radical 6 plus x squared radical 6. So you notice that there are 4 terms here, but really of these 4, only the first 3 are like radicals. That's because they have the same in variable and same in radicand. So what we do is we combine the numbers in front of them. So there's the 5 plus the 7. So 5 plus 7 is 12, and then 12 minus 3. So that comes up to be 9. So the answer is going to be 9x radical 6. But the last piece that's different, you leave them the same way. So it's going to be x squared radical 6. Okay, so, and that's the best you can do. You can't go any further. So the bad news is we hardly ever give it to you like that. So what you will more likely see is, for example, what's radical 150 plus radical 24 minus radical 27 minus radical 6, for example. So at one glance, you notice they seem to be all different. But what you can do is simplify each one. So what does this become, and what does this become, and what does this become? So let's try 150. First choice would be 15 and 10, but that's useless to me, so I'm going to break it down. 15 is 3 and 5, and 10 is 5 and 2. So 5 and 5 is what gives me 25. And the 3 and the 2, one piece of each, I'm going to combine it and call it 6. Plus, for 24, we're going to use 4 and 6. For 27, 9 and 3 will be a good choice. You notice we always pick a perfect square and something that's not perfect. Now 6 is a special one. I can't do much with it. Okay, so what is radical 25? That's 5. And radical 6 stays as radical 6. 2 radical 6 minus 3 radical 3 minus, now if you don't see a number, it really means 1 radical 6. So looking at the terms, that's radical 6. So is this. Missed that one, but this one is radical 6. So these 3 are what you call like terms. So you have 5 plus 2 minus 1. So 5 plus 2 is 7. 7 minus 1 is 6. So this answer is going to be 6 radical 6. But the 3 radical 3, you just leave it. Okay, and that would be the answer. Now this really applies to any type of radical. It could be square root, it could be even fourth root or any root. For example, if you have 7 cube root of 7 minus 3 cube root of 7. So if you look at the radical portion, they're the same. So that means you now have permission to combine them. So 7 minus 3, so it makes it 4. But apples and apples is still apples, so you keep it as radical cube root of 7. Okay, so you don't change it. So you started with 7 and you lost 3, so your answer become 4. Okay. So like I was explaining to you, sometimes we kind of camouflage the story so it looks like, for example, 13 cube root of 320, and I wish to add to 2 cube root of 40. So when you look at this, you notice that at one glance they look different, but I can try to simplify this. So this is cube root, so you're going to have to think a little bit. Let's work it over here. For cubes, 8 is a good number, okay, because cube root of 8 is 2. So 320 is going to be 8 times 40, and 40 I'm going to break again as 8 and 5. So 8 and 8 is both perfect cubes. I can combine them. So I'm going to write this as 64 times 5. On this one, I'm going to break down the 40 as 8 times 5. Okay, so remember, cube root has a different rule. Cube root of 64, meaning what times what times what 3 times, will give you 64. So the answer is 4. Just as when you take cube root of 8, you're asking yourself what times what times what 3 times will give you 8. So the answer is 2. Okay, so this is going to be 13 times 4 cube root of 5 plus 2 times cube root of 8 is 2, and 5 stays inside the cube root. Okay, so what you have, let's see, 13 times 4 is 52, cube root of 5 plus 4 cube root of 5. So you notice you can't tell whether they're like radicals. You do have to simplify first. Okay, so that's what you have to do, simplify first. Now if you stare at the radicals, you notice they're the same. Okay, once they're the same, you have permission to combine the number in front of it, which we call the coefficient. So 52 plus 4 makes it 56, and that will be cube root of 5. Okay, and that will be the answer. So these rules of combining radicals, it works for everything, except a lot of times we kind of hide it a little bit, so you're going to have to simplify first. Okay, watch out for that, simplify first. Now, let me show you more examples, but before I do that, let me get you to recall 2 rules. One is product rule, which says that if you have radical A times radical B, this is radical AB. Now let's extend this rule a little bit. What if now there's a number in front of the radical A and there's another number in front of the radical B? Okay, then all you have to do is outside with outside, multiply together, and inside with inside, multiply them together. Okay, so this is an extension of the product rule, but the concept is the same. Quotient rule, you've seen it as well. And all this rule says is that if you have radical A over radical B, equivalently, it's like if you put A and B together. So let's call this example 5. What did we say? Simplify. Okay, simplify. But what you end up with is 2 radical 3 multiplied to 2 radical 5 minus 4 radical 6 plus, say, radical 98. Okay, so at one glance you notice that where do we start? Okay, so the usual way, you are going to have to remove the parentheses first. So let's distribute. So 2 times 2, remember outside with outside, inside with inside. Okay, so let me write the rule here. So C times radical A multiplied to D times radical B. Then the C combines with the D, so it's CD. But the A and the B, they're both in the radical, so they stay in the radical as a result. Okay, so same here. So 2 times 2 is 4. And radical 3 with radical 5, that's radical 15. So in multiplication, you're allowed to multiply them even though they are different radicals. Okay, it's only when you add or subtract that you need them to be the same. Alright, let's do this. 2 radical 3 with 4 radical 6. What is that? That's 8 radical 18. Okay, and then plus square root 98. So there you have it. There are 3 terms in total. So it's too soon to tell if they are even the same thing. So let's simplify them further. For 15, there's not much we can do because it's 5 times 3. So I'm going to leave it as 4 radical 15. Now, what about 18? So 18, I can call it 9 times 2. Okay, 9 is perfect, 2 is not. 98, I can use 49 times 2. Okay, and 49 is a good number because square root of 49 is 7. So 4 radical 15 minus 8 times radical 9 is 3, radical 2 plus, let's see, root 49 is 7, radical 2. Okay, so what you have is 4 radical 15 minus 24 radical 2 plus 7 radical 2. There you have it. So we have all of them simplified as much as we can. And then you look again. Oh, there you have it. There's 2 radicals. That's the same. Now remember, the negative belongs to the 24. So it's negative 24 plus 7. Okay? So 4 radical 15 stays. You don't get to go away. But negative 24 plus 7 is negative 17. Okay? Negative 17. And radical 2 still stays as radical 2. So when you are adding radicals, the radicals do not change. It's only the coefficient that changes. Okay, it's when you are multiplying that both will change. The coefficients, when they multiply, will change, and so will the radicals. So what other ways can we ask you the question? We could also make you FOIL. Like, for example, I say, can you simplify? Let's try radical x minus 2 radical y multiplied to 3 radical x plus radical y. So you notice there's 2 terms here and there's 2 terms here and they're multiplied together, so you have no choice but to FOIL. Okay, so let's multiply. Remember, outside with outside, inside with inside. So what do you have here is 3. Okay, because the number outside really means 1, so 3 times 1 is 3. Radical x with radical x is radical x squared. Okay, radical x with radical y is plus radical xy. Minus 2 radical x with 3 radical y, x with radical y is negative 6 radical xy. And finally, negative 2 radical y with radical y is outside with outside, inside with inside. So it's negative 2 radical y squared. Okay, so let's clean this up. 3x squared, x squared and squared, so that's just 3x. There's no leftovers. This, radical xy and radical xy. Oh, you guys are the same. So I'm looking at the number in front. Okay, so this is a plus 1 minus 6. Plus 1 minus 6. So that's negative 5. Apples and apples, still apples. Okay, so you don't get to change the radical portion. Minus, and that's going to be 2y. And then now you look, they're all different. And that's it. You can't combine them anymore. Okay, that will be it. Okay, let's try one more example. Supposedly I say, can you simplify 7 radical x plus 2 radical y with 7 radical x minus 2 radical y? Now, in this case, you know the same thing, I have to FOIL, so 7 and 7 is 49, x and x is x squared, root x squared, okay? And 7 with 2 is negative 14, root xy, but the inside is going to be plus 14, root xy. And then you have minus 4, root y squared. Now, unlike before, you notice that these two pieces in the middle, they have the same radical, so they are like radicals. And the coefficient in front actually cancels. Okay, that's minus 14 with plus 14, they cancel. As in, they become 0. So what's left is actually 49x. Okay, and the one in the back is minus 4y. Now, you notice that the radicals are gone. Okay, so why is this example so special? If you stare closely at these two terms, you notice that it's like 7 radical x in one, the other one is also 7 radical x. The one in the back is 2 radical y, and this is also 2 radical y. The only difference between the two parentheses is that one is a plus and one is a minus. So these guys are what you call conjugates. Okay, and when conjugates come together, you notice that the radical terms always cancel. Okay, keep that in mind because that's what we're going to revisit when we go to 8.4. Okay?